All right, class, settle in. Have you ever found yourself staring at a giant spreadsheet, just a wall of numbers, and thinking, what am I even looking at? Or maybe you've scrolled through hundreds of product reviews trying to figure out if that new gadget is actually any good. You're drowning in information, but you're starved for wisdom. Well, that's exactly where we're going to start today. Because hidden inside all that noise, there are incredible stories just waiting to be told. And we're going to learn how to find them.
So here's our game plan for today. First, we'll cover the fundamentals, something we call exploratory data analysis, using a real classic numerical dataset. Then we're going to jump into the deep end, the messy, wonderfully human world of text, with a massive dataset of food reviews. We'll unpack the cool techniques we use to make sense of it all, and then we'll tie it all together to see why this stuff really matters.
And this is the big question, isn't it? In a world that's just saturated with information, how do we get from raw data to a genuine discovery? You can have the most powerful computer, the most complex algorithm on the planet, but if you just throw it at a pile of data without asking a good question, you're just going to get a faster, more complicated version of noise. The real magic happens when human curiosity takes the lead.
Okay, so let's get into our first topic, exploratory data analysis, or, as we call it, EDA. Now, I want you to think of this less like a rigid science and more like being a detective. Your data set? That's the crime scene. The clues aren't footprints or fingerprints. No, they're weird spikes in the data or a strange cluster of negative reviews that all happen to use the same word. Our job is to spot those things and ask, why did that happen?
So, to put a more formal definition on it, EDA is the absolute first thing you do on any data project. Seriously, before you even think about building some fancy predictive model, you've got to roll up your sleeves and just get to know your data. We use some basic stats, and most importantly, we make plots. We visualize it to really understand its shape, its quirks, and all of its hidden potential.
All right, to make this real, we're going to start with a true classic. This is a rite of passage for anyone who studies data science, the iris flower dataset. It's simple, it's clean, and it is absolutely perfect for showing the power of EDA with numbers. And this is what we're working with, a simple table. We've got measurements for things like sepal length, petal width, for 150 different flowers, and we know which species each one is. Now, just by looking at these rows of numbers, can you see the pattern? Of course not. It's pretty much impossible. The story is completely buried. So, the first thing any data scientist would do is try to visualize it. Let's make a simple plot, sepal length versus sepal width. And what do we get? Well, we get a blob, a single messy cloud of dots. I mean, we can kind of see the range of the data, but that's about it. There's no real pattern here. It's not telling us much. But now watch this. We're going to make one tiny change. We're going to give each dot a color based on its species. And bam! Just like that, the chaos organizes itself. Suddenly, we have clarity. This is the aha moment of EDA. You can see right away that the iris setosa flowers, the blue ones, form their own distinct little group. The story is starting to emerge. Okay, so why stop there? Why just plot two things against each other? With a tool called a pair plot, we can plot every feature against every other feature, all at once. It's like running a dozen mini experiments in a single chart. And when we look at this grid, one thing becomes crystal clear. The charts that use petal length and petal width, they show the cleanest separation between all three species. We just found our most important clues.
Okay, so we've seen how to find stories in nice, neat, orderly numbers. That's great. But let's be honest, most of the data out there isn't like that. It's messy. It's human language, emails, reviews, social media posts. So the big question is, how on earth can a computer, which only gets ones and zeros, possibly understand words?
And for this, we are jumping straight into the deep end. We're going to look at a data set of Amazon fine food reviews. And I mean, this thing is huge. We're talking over 500,000 reviews written by real people about everything from coffee to potato chips. Our mission is to see if we can teach a computer to automatically tell if a review is positive or negative.
Now, before we do anything cool, we have to do the dirty work. We have to clean this text. This is the EDA for language, and it is absolutely crucial. We've got to strip out junk like HTML code, get rid of punctuation, make everything lowercase. We also remove super common stop words like a, the, and is because they don't really add much meaning. And a final step called stemming chops words down to their root. Trust me, this cleaning part, it can easily be 80% of the entire job.
So, once our text is squeaky clean, we hit the main challenge.
We have to convert all these words into numbers. The fancy term for this is vectorization, but I want you to just think of it as teaching the machine to read. We're creating a mathematical representation of language so the computer can finally work with it.
So, the simplest way to do this is a method called bag of words. It sounds a little silly, but here's how it works. First, you make a giant dictionary of every single unique word that appears in all 500,000 reviews. Then, for each individual review, you just count. How many times did the word delicious appear? How many times did awful appear? That list of counts becomes a long string of numbers, a vector, that is basically a numerical fingerprint for that review.
Bag of words is a great start, but it's got a big flaw. It treats every word as equally important. So a smarter approach is something called TF-IDF. The key idea here is that a word like delicious is probably more important than a word like the. TF-IDF gives a higher score, a heavier weight, to words that are rare across all documents, but pop up frequently in one specific review. It helps us find the words that really matter.
But then you get to the next level, a technique called word-to-vec. And this is where it gets mind-blowing. Instead of just counting words, word-to-vec actually learns the context and the meaning behind them. It creates these numerical fingerprints where words with similar meanings are mathematically close to each other. It understands that king is to queen as man is to woman. It's not just counting words anymore, it's starting to understand relationships.
So, let's zoom out. We've gone from a confusing blob of flower measurements to clearly defined groups. We've taken 500,000 chaotic human reviews and started teaching a machine to understand sentiment. These seem like totally different problems, right? But they are connected by one powerful idea: the process of turning raw, meaningless information into actionable insight. It's about finding the narrative in the noise.
So if you walk away with anything today, I want it to be these 4 things. 1. Visualize your data, always. A single chart is worth 1,000 spreadsheets. 2. Clean data is everything. Remember the saying, garbage in, garbage out? It's true. 3. Context is king. The best technique for numbers is not the best for text. And finally, number 4, every dataset has a story. Your job is to be the person who finds it and translates it for the rest of us.
And that's where I want to leave you. Think about it. Whether it's in a spreadsheet for your job, the data from your fitness tracker, or even just the text messages on your phone, you are surrounded by data. So the real question is, what stories are hiding in your data, and how are you going to be the one to find them?